Hi guys, how are you all doing? In this video, we'll take a look at reverse bits problem. Difficulty level is easy, so let's see what the problem is. So we're given a 32-bit unsigned integer and we need to reverse the bits of that integer. Now, the problem is straightforward. However, the challenge is like we're given a number, so that's an integer number, and within that integer number itself, we need to reverse the bits. So it's not like a string where we need to reverse the character, but we need to reverse the bits within an integer. So there are a couple of examples. We can take a look at those examples. Like they're good examples. Like they have taken large numbers, so it's a good examples. However, like if you want to understand in a simple example, let's say we are into a 4-bit system, like our numbers are represented in 4-bit, then 8 would be represented in binary as 1, 0, 0, 0. So 1, 3 zeros. And if we have to reverse that number, it would become 0, 0, 0, 1, right? So 1000 would be reversed to 0001, but that would be in a 4-bit system. Now we are given a number, integer number, which is a 32-bit system. So we'll see how we'll do that. So at the top, this problem does sound a little bit intimidating, but once we know how we'll solve it and once we know the trick behind it, it's really a fun problem. So let's do that. Let's understand how we'll solve it. Okay.
Okay, so guys, this is our whiteboard for reverse bits problem. So I've taken our number as 22. I know in our problem description I spoke about number 8 and 4-bit system, but then I thought that was like too small example, like 4 bits would be like too small. So and 32 bits will be too big. So I said like let's look at the 8 bits, let's try to figure out that, and then the approach remains same whether you have 4 bits or 8 bits or 32 bits, so doesn't matter. So for this example we'll look at 8 bits, we'll try to understand the flow, and then we'll make sure that it obviously needs to run for 32 bit, right? That's the whole goal. So we'll go to the computer and then we'll run it for 32 bit numbers. So first let's understand for 8 bits and then apply that for the actual code. So what we have done is we have taken number as 22. Now 22 means 16 plus 4 plus 2. So in bitwise it will be 2, which is this bit, 4, which is this bit, and 16, which is that bit. So 1 is 0, 8 is 0 because it's 16 plus 4 plus 2. So that's bitwise representation of 22. And we'll take a result variable, which is again 8-bit number, and we'll start that with 0. Now to reverse these bits into result, we are doing 3 steps. So step number 1, left shift result by 1 bit. So move all the bits by 1 place to left, and the new bit would be 0 obviously. And then look up the last bit in n. If it's 1, make that bit 1 in the result, and then right shift this n. That's the step number 3. So right shift n by 1 bit. So keep moving this bit by 1. So these are the 3 steps. Let's do it and let's see if we can reverse 22. So a reverse would probably mean like a mirror image. So like reverse would be completely mirror image of these bits. So let's do that. Okay, so I have this result. Will left shift this result by 1 bit, right? So left shift of all zeros would be same. So it'll be 0 0 0 0 0 0 0 0. And now what we do, we look at this bit. If it's 1, we make it 1. If it's 0, we keep it 0. Now in this case it's 0, so we don't do anything. Now third step, we right shift this by 1 bit. So this will become 0 0 0 0 1 0 1 1. So we are moving by 1 bit. Now let's repeat. We'll repeat this 8 times and then we'll get our reverse integer. So again left shift. So 0 0 0 0 0 0 0 0. Now second step, we look at this bit. In this case it's 1. So what do? We make this bit as 1. So you can do +1 or you can do a OR operator in bitwise, anything is okay. we'll look at those when we go to the code. So now third step, right shift this guy. So 0 0 0 0 0 1 0 1. So this last bit is gone. We have new bit 0 on the left. So it's right shift. Now we'll keep repeating this. So
left shift this guy. So 0 0 0 0 0 0 1 0. So second step, we look at this bit, it's 1. So we make that guy 1. So we make this 1, right? And we right shift this guy. 0 0 0 0 0 0 1 0. So we're moving by 1 bit. Now we'll do those 3 steps again. So 0 0 0 0 0 1 1 0. Now we take a look at this. This guy is 0, so we don't do anything. Now we right shift this guy by 1 bit. 0 0 0 0 0 0 0 1. Now same thing. Left shift by 1 bit. Now we look at this bit. Second step. Since this bit is 1, we make this guy as 1. So, and our third step, we right shift this by 1 bit. So 0 0 0 0 0 0 0 0.
So now since all the bits are 0, we have 3 more steps remaining. So we'll just repeat those 3 steps 3 more times and we'll see what we get. So let me do that.
So 0 0 0 1 1 0 1 0. Obviously all this would remain 0, so I'm just marking it as 0. Now this is 6 steps. 7 step would be 0 0 1 1 and then 0 1 0 0. There's one more step, 1 2 3 4 5 6 7 and then 0 1 1 0 1 0 0.
So there you go, guys. We have our starting number as 0001 and our reverse integer is 0001. Then we have 0110, 0110. So that's exactly reverse of 22's representation in bitwise, obviously. So that's the approach. Let's go to the computer. Let's make sure that this approach runs for a 32-bit integer. I'm sure it doesn't make a difference whether it's 8-bit or 32-bit. We just simply apply this logic and it'll run. So let's do that.
Okay guys, this is our code for the approach that we did on the whiteboard. So if you remember 3 steps, that's exactly what we are doing. So our step number 1, left shift result by 1 bit. Our step number 2, check the rightmost bit in n, and if it's 1, then make that 1 in result, which is result plus plus. You guys can do this also, right? Result or n and 1. Both of them are same thing. So whichever is more comfortable. And then our third step, move n by 1 bit, like right shift n by 1 bit. And obviously we do this for 32 bits. And for if we do that for 32 times, obviously result would have reverse bits of n. Let's run our code. Let's make sure that's what it is and then confirm. So let's run it and then it'll run against sample test. Yeah, there you go. Actually, I want to show you guys one more thing. So let's go back to the problem. Yeah, so description. And now if we scroll down, there is a follow-up question. So the follow-up is, if this function is called many times, how would you optimize it? So let's say if we have million numbers and we're calling this function million times to reverse each integer. And the question is, how would we optimize it, right? Because since we are running the loop for 32 bits, 32 times, it still takes time. So the question obviously is there any better way to do it? So first of all, yes, there is a better way to do it. And let's figure out that what that way is. So what we'll do is we'll first look at the code. You guys can already see the code. We'll run the code. We'll make sure we get the expected output and then we'll backtrack. We'll try to understand why that code is doing what it's supposed to do. So let's run this code. So let me change this method name to the one that Leetcode would call. So this is, so we're doing 5 steps, technically 10 steps, and then we are getting our output. So if you're doing 10 steps, that's definitely better than 32 steps, right? So that's a definite optimization. So let's run this code and make sure that we get the expected reverse integer. Yes, we do. Okay, so now we need to understand why this reverses all the bits in the integer. So what I did was I'm trying to explain this in Excel instead of whiteboard because it's really complicated in whiteboard. So let's see that Excel. Okay, this is our Excel. I know it looks a little bit overwhelming, but just be with me and then everything will get clear. So let's look at what we are doing in this Excel. So first of all, I have some alphabets, right? So I have A to Z and then more A to F in uppercase. So these alphabet represents the 32 bits in a number integer, 32-bit integer. So these would represent those 32 bits. So we have 26 alphabets, so that's why 26 alphabets, and then I used uppercase A to F to make it 32. So those are our 32 bits. Now in code, if you notice, our first step was an end with FFF 4F and then trailing zeros, and then right shift by 16 bits, and then four zeros, and then 4F, and then left shift with 16 bits. So that is what we are trying to mimic here, and that is what we are trying to understand what is happening over there. So before that, obviously this FFFF and 00 is a hex number. So let's just take a quick look at what is hex means. So hex numbers are 1 to F. So if we compare them with decimal, they would be like 1 to 15. So up till 9 they are same, and then 10 is A, 11 is B, 12 is C, and likewise 15 is F. So that's what this FFFF and 000. So it's a 32-bit number which is represented in hexadecimal. So now let's see what that does, right? So this is our FFFF and these are our 40. So if we represent them in binary, this is how it will look like, right? So now we are comparing this 32-bit our alphabets with this number, which is initial 16 0, initial 16 bits 1, and then last 16 0. So if we and those operator, this character a and 1 would be a. I mean, not in literal sense, like, but imagine if this a was 1 or 0. So whatever that number is, you and it with 1, it'll be that number. So since we are assuming them to be alphabets, we'll take those alphabets. So when we and those 16 digits with 1, obviously those 16 digits will be as is, and then Q to remaining alphabets, when we AND them with 0, they'll come as 0, right? You AND anything with 0, it's 0. Anything AND with false is false. So now our next step is we right shift those by 16 bits. So when we right shift this by 16 bits, this is how our number will look like, right? Now the second part of that step or the later part of that step. So same string or same characters representing 32 bits. Now in this, we are focusing on the end 16 bits or trailing 16 bits. Our number, the hexadecimal number is first zeros and then 4F. So they'll look like as first 16 digits are 0 and then last 16 digits are 1. So when we AND those, first 16 digits become 0 and last 16 digits come as what they are. So the characters that we have. And now what we do, we left shift them by 16 bits. So this is how it'll look like. And when we OR these two operations, we'll get our full 32-bit number. So let's see how that will look like. So this is how it will look like, right? Our Q to F would come in the first 16 bits, and our A to P, the first 16 bits, will come into last 16 bits. So that's our first step, right? Now let's look at our second step. So in code, this is our second step. So let me put that second step in Excel. So this is our second step. And we take our number from the first step as is, and what we do is we AND it with FF00 FF00. Now we all know F is 1111, so basically we are saying that 8 ones and then 8 zeros and then 8 1 and then 8 zeros, and then complement of that 8 zeros, 8 1, 8 0, 8 1. So let's see what that first half of the step will do. So we are working on 8 digits. So we'll AND those and then we'll right shift them by 8 bits. So QRST UVWX will come here and ABCDEFGH will come here. So that's first part of that step. Now that second part of that step would what it'll do, YZABCDEF will be left shifted. So they'll come here, and then likewise IGKL MNOP would be left shifted and they'll come here. So now slowly bits are getting placed to their correct position. They're going towards their destination. So that's second step. Now let's see what happens in third step. Okay, this is our third step. Now I think we can go quickly, right? You guys got the gist of it. So what we are doing is we are doing AND operator, not ANDing, AND operator with F0, 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 and then right shift by 4, and then complement of that 0F, 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 and then left shift by 4. So what that'll do, it'll take 4 bits, which is F1111, and it'll right shift. So YZAB will come here, QRST will be right shifted by 4, IJKL would be right shifted by 4, ABCD would be right shifted by 4. And likewise, the second part, a left shift by 4 bits, right? CDEF would come here, UVWX will come here, and MNOP would come here, and EFGH would come here. So that's step number 3. Now let's go and look what step 4 would do. Okay, this is our step 4. So now you'll notice that we are doing AND operation with CCCCC, and in later half we are doing it with 3333. Now, if you remember our hex value to binary value, so what does C mean? C means 12, which means 1100. So we are doing 2 bits at a time. So CC would be 1100, 1100, and that's what. And 3 means 0011. So 3333 would mean 0011, 0011. So that's what we are doing. So we are operating on 2 bits. So that means our CD would be right shifted, YZ would be right shifted, EF would be left shifted, AB would be left shifted. So now we are shifting 2 bits at a time. So now if you look at our string or 32 bits, from the backside it's BACDCFEGH. So our final step should be just exchange these 2 bits, right? Exchange these 2 bits. If we do that, it'll be A, B, C, D, E, F, G, H likewise. So it'll be exactly reverse of what we started with. So let's look at our last step. Okay guys, this is our last step to reverse all the 32 bits. Now what we are doing AND with A, and with 55555. Now let's look at binary representation of those numbers. So A is 1010, that means alternate bits, and 5 is 0101. Again, alternate bits, but complement of 10. So if I can highlight, so oops, and so there you go. 10 and 5 are complement of each other. So what we are doing, we are taking 1 bit at a time and then we are right shifting or left shifting. So E would be right shifted, C would be right shifted, A would be right shifted, and likewise all the one which are in green would be left shifted. So F would be here, D would be here, B would be here, and likewise. Now if we read our string from back or like to end to start, it'll be A, B, C, D, E, F, G, H, and that's exactly reverse of what we started. So that's what the code does, guys. So that's it, guys. We transformed our bits to alphabets to understand better, and then see that those are actually reversed. So that's it. That's the answer to the follow-up question. That's the optimization that we can do. So I hope you guys were able to understand. I hope that Excel was not overwhelming. So if you guys like that, if you guys like the video, if you guys like the explanation, give me thumbs up. Let me know your feedback and suggestion in the comments. If you have any questions, let me know in comments. And then as usual, subscribe to the channel for more videos. See you in next one.